You may remember when we go for exams and we study the night before. So whatever we study the night before comes in from our textbooks. And the textbooks is nothing but the secondary storage, the hard drive. It can come from your iPad, it can come from your YouTube video. All of that is secondary storage, not the primary, because that is not our brain. When you load that information from your hard disk to your brain. Hi everyone, welcome to my channel Code with Ease by Varsha. So this is the System Design 101 series which we have been doing. These are the videos which we have already covered so far as part of this series. Today we'll talk about today we'll talk in depth about caching in system design. Watch this video very carefully, attentively, take your notes, and also I'll link in the description the documentation for this. But this is going to be the very foundation, after which when we will study more about other technologies and other concepts of system design, this concept of caching will be very helpful. So must watch this till the end of the video. So let's begin. Okay, so starting now, we understood that caching is using the locality of reference principle, which means any data which has been recently requested is most likely to be requested again. So before we understand about this term caching and what it implies, we have to understand the origin of this term comes from cache plus ing, which is the verb like it is doing something. So using the cache to do something is what caching is all about. So what is this do something? We will discuss about that. But first, let's try to revisit what we know about cache. So our first encounter with cache happened way back when we have studied about computer hardware in our school days, right? So when we know that we have CPU, there was hard disk, there was RAM, and RAM is the main memory. So our running programs, temporary files, everything the CPU needed access to, actively needing access to, was available in the RAM. So CPU and RAM had this connection. But in between, later on, we understood there is one more piece of hardware which comes in, and that is called cache, which is again having different levels, L1, L2, L3, L1 being the closest to the CPU. So this is just a quick revision of what we know about cache. Cache was faster than RAM, much faster than hard disk. So between RAM and CPU came in cache because it was faster, although it was smaller, but it was faster. So because whenever it needed access to any data which was critical, frequently accessed, CPU used to take it from the cache, and not from the RAM. So when we know that this is what the primary use case is of cache, and that is what we are going to use in the world of system design to apply it on large scale distributed system. The same concept, the smaller size but much faster performance. Latency will be lesser. So in order to in order to increase the data retrieval speed is why we are going to use cache in the world of system design. So understanding of this origin of where cache is coming from, what are we actually borrowing from this concept of cache and how are we applying it on a large scale system is what is important to understand even before we go dive deeper into caching in system design. So with that, let's begin. So first, starting with some examples that we see of cache, like how cache is being used around the apps that we mostly use daily, like Spotify, where whatever song that you are playing, every time when you are playing the same song, do you think it is getting loaded from the database? It is not. And that is again the locality of reference principle. So you played the song. The probability is maybe in another 5 minutes, you again want to replay the song if you like the song. So in that case, again fetching from the DB not possible. So let's say there is a business logic, for example, that we will cache the songs for 1 hour. Because for 1 hour, the same person might be listening to music and they might play the same song again. So we'll use cache to, I just give an example of a sample business logic. It can be different from different companies, but the point is it will temporarily cache the song so that if you play the song again, it will load it instantly. There is no latency. The next is social media. Almost every single time in a day, you will open your Facebook or Instagram multiple times. So every time when you are opening your app, to improve your browsing experience, your feed experience, the news feed experience to be better, they are not going to load all the photos, posts, videos from the database again and again. They might be cached, for a limited number of time. It can be 1 hour, it can be 4 hours, it can be anything. But they would like to keep it in the cache for some time so that it becomes seamless, the browsing experience becomes seamless. Similarly, in food delivery apps. So let's say if a person wants to order food, usually the possibility is within 1 hour, we will try to order the food maximum, let's say. So Zomato, Swiggy, whatever. So in that 1 hour, if I load all the list of my nearby restaurants in the cache, in my cache, if I load it, so that the person while scrolling and trying to figure out where to order the dish from where, I will be able to deliver much faster experience to the user because I have cached the restaurants and the menu information and everything. So this will allow you to place your order faster so that you don't have to wait for the data. The person is already hungry and is scrolling and browsing through all the restaurants. Every DB fetch is going to be making him more and more impatient and disrupt the user experience. That is why we'll use cache. So now, these examples are always around us. Every single day we are interacting, but it doesn't come to our mind. So that is why it is important how this concept is being applied. The what we learned in the computer hardware, that concept is being applied in every single app that we use. Now, coming to some industry use cases, these were like the local things, like what we use it based on the functional point of view. If we talk about in terms of technical languages, now your e-commerce site also caches your product images and details in the memory. So when you go to your Amazon, Flipkart, you are trying to order something similar to the above examples, that they want to reduce the load on the database and speed up the page load times. So they will cache the product details. Content delivery networks is a fantastic use case of this concept of caching. We'll come to that. They also would want to cache all the static content that you use, because people will read news once they wake up in the morning. So they will cache all this static content across multiple ad servers. So this is with respect to global network of cache, you can think. So global network of cache. So that the news which is originating, so this reduces the distance data must travel. So basically, in India, I can have 3 or 4 edge servers. So that as an Indian, when I'm reading the news, my news, which the server of which may be in USA, but let's say the news, the data, like the image of the news, the post and everything is getting cached in the nearby edge servers across India. So that the content of the news is being served from those servers and not from the servers which are located outside of India. That is one use case. Third is database query caching. So not just keeping the information. So your financial services company pre-calculates and caches the complex reports. Okay. So like for example, your stock market news, your Zerodha, Grow app, your mutual funds, all of them would want to, let's say, pre-calculate the summary, like what happened yesterday with Nifty and Sensex. So they would want to pre-calculate all of that and keep it ready, so that in the morning when people will open and see the trends, what is the trend of the market right now, they do not have to run the complex database queries every day at 8 a.m. in the morning. Why will they do it? Rather, they'll compute it at, let's say, 3 a.m. in the morning and keep it ready. Next is social media platforms. You might see the friend recommendations will come. Then you may see that some stories are getting suggested. That is also pre-computed. So this term, that pre-computing, is very much relevant when you apply caching to your day-to-day life. So pre-computed results is what is like the pre-calculated or pre-computed results are quickly served to the end users. And that is done only and only by using the concept of caching. Coming to the formal definition of caching, that it involves temporarily storing data in faster storage to reduce the time taken to retrieve the data. And it also talks about if a data is found in the cache, then we call it a cache hit. And if it is not, we call it a cache miss. One funny example is coming to my mind is it's very real. Our human brain also functions like having a small cache in our brain. So you may remember when we go for exams and we study the night before. So whatever we study the night before comes in from our textbooks, and the textbooks is nothing but the secondary storage, the hard drive. It can come from your iPad, it can come from your YouTube video. All of that is secondary storage, not the primary, because that is not our brain. When you load that information from your hard disk to your brain, now it gets loaded into our brain. And interestingly, in our brain, you can think of it as the cache, because the next day when the exam happens, all the information are going to be pulled in from this cache, from this cache. You can think of it as cache, you can think of it as RAM, but it is the faster the responses come, then you can think of it as cache. But that's not the point. The point is even that is temporary. Just a week later, you forget all the things you have remembered. Maybe you'll just forget after giving the exam itself. So that is how it is. It gives you the fast retrieval because it is stored in your brain. The context is loaded in your brain. It's there fresh and it can be easily retrieved. But again, it is temporary and the size is also small, and that is what is referred to our memory, the human memory also. So now in the context of this, so why are we using cache? If you relate to this example, you'll be able to understand all the reasons why. Like performance, of course, we want that to reduce the time to serve the request. We want the latency to be lesser, and we want to lower the database load. We don't want to overburden because database operations, the disk IO operations are expensive. So we want to get the results with fewer database queries. And again, locality of reference, like I gave the example of the song playlist in Spotify. If you have listened to that song, if you have listened to that song, the probability of you listening to that song again is high, and that is why recently requested data is likely to be requested again. So that is why you should be using cache. Moving on to the types, we have 5 types: client side, server side, database caching, then we have CDN caching and distributed caching. So client side is mainly when all the assets, your static assets, your images, then anything which is required to serve the static websites, all of that assets are stored on the client side browser, on the mobile app itself. When we used to just play around with doing app development, mobile app development, we might have seen this. And then why we are doing this is because we don't want the repeated downloads of the same assets to happen. So we try to cache it on the end user's browser only. So that the next time you visit the site, it will load faster. So this is client side caching. The most popular, the most prevalent is the server side caching, where the server takes care of keeping all your frequently accessed data in some data storage. Like it can be any kind of in-memory cache, it can be distributed cache, it can be anything. But the onus is on the server, on the application server, who want to improve the data retrieval and they also want to reduce the load on the databases. The next is database caching. Now, when the database vendor also wants to speed up the query results that it is trying to run, by doing that, it is referring to the internal mechanisms of the database. The database has its own mechanism of retrieving a certain query from, let's say, a table of 1,000 rows. So when it is trying to do it, all the frequently accessed queries, the common queries and everything, it can try to cache the results of those as well. So that even if we do again and again the same select query, it will not run the same query actually. It is going to maybe give us the data from the cached result, which the database vendor's implementation is doing. So that is another level of caching which the database itself is doing, apart from the server-side caching which the developers like us will be taking care of. But database caching is done from the vendor perspective. Next is CDN caching. Like we were talking about CDN, I like to think of it as global network of cache. So if you want to read news, you're located at Delhi, the news articles, posts, images, whatever, it will be served faster from a server located at, let's say, Pune than a server which is located in Tokyo. And that is the entire concept, that they want to speed up the content delivery for global users and reduce the load on the origin server, which means where the data is actually located, the origin server. Next is distributed caching. So distributed caching and server-side caching, both of them are very prevalent nowadays. Now, why distributed caching has come into place? Because in large-scale systems, the caching is spread across multiple nodes. You cannot have just one single cache server. What if that server goes down? We don't want to have single point of failure. So this approach will handle the high volumes of data and traffic across the multiple nodes, again ensuring availability, reliability, because we have multiple cache instances, so that whenever any data is required from any of the cache server, it will function as a distributed cache and it will be able to get me whatever data is required from that, even if I have a spike in traffic, even if I have peak traffic, or whatever be the case. The reason why load balancing and everything has come into pictures because of this, right? High scale traffic requirements. So in that case, when you're serving millions of users, you do not just want your load balancing of the app to happen, but you also want the business logic part of it to be taken care of. So over there, if you're fetching data from a cache to serve something, the cache instances should also be replicated. There should also be multiple cache instances to prevent the single point of failure. So that is where your distributed caching concept has come from. So these are the types of the caching. Next up, we would like to talk about the caching strategies. So we read about what are the different types of caching. Now, given a type of caching, what are the different strategies that you can take? Or what sort of caching algorithm basically you would want? So if you are thinking of, there are two aspects to it. Any data can be two things. Either you read the data or you write to that data or you do both. So if the perspective is from reading data, one strategy is called cache aside or lazy loading. So as the diagram suggests over here, what are we doing here? We have an application, we have a DB, we have a cache. Okay. So now over here, what are we doing? The application will first check in the cache for the data. If it is there, we will have a cache hit and we will get the data. But if it is not found, the onus is on the application to fetch the data from the DB. And the onus is also on the application to store it in the cache. So it is completely application controlled. This is lazy loading. Whenever the app needs it, the app will call the cache. If it found in the cache, then it will have a cache hit. If not, it is going to get the data from the DB also, get the data from DB plus update the cache also. So this is the lazy loading. Next strategy is called read through cache. Over here, the onus is not on the application. As you can see on the diagram, now the onus is completely on the cache. And read through is also known as eager loading because the cache doesn't want the application to take the ownership of this. So that is why what happens is now like it is mentioned, if the data is not in the cache will itself fetch the data, and it will fetch the data, keep it ready in the cache, and the fetch data will be returned to the application and stored. So this is the read through cache. So now talking about writing data. So the first strategy is called write around strategy. So in case of read, when it is trying to read, it will try to read from the cache. If data exists, great. But if it doesn't, then it is going to read from the DB and it is also going to update the cache. This is the write around strategy. So you are just bypassing the cache and writing around it. That is why it's called write around. Next is write back or write behind. So over here, what we can see is here, just opposite to what we have seen in this case, the application is writing directly to the cache and the cache is writing to the DB. So there is no connection between the application and the DB. And in case of write through, application is writing to cache is writing to DB immediately. The difference between write through strategy and the write back is the cache will do a asynchronous write to the database, maybe after some time. So it will be eventually consistent. Now, in case of write through strategy, you write to the cache, application writes to the cache and cache is immediately writing to the DB. This is the difference between write through and write back. And write around, like around, when you see the word around, you have to understand there's a bypass of the cache happening. Okay, so now the very general question will be when to use which strategy. So first we will compare the read strategies, right? So first is read through versus cache aside. Remember, read through is also called eager loading. Now, in case of read through, as we know that the cache had the upper hand, and in case of cache aside, cache is kept aside, so the application has the upper hand. So application will load the data into the cache when needed. But in here, cache and database both are in consistent state. So here cache handles the loading and application decides when and what to cache. So which is why in case of read through, the cache will always have the latest data. But in this case, the cache may not be ahead, cache may not be consistent with the data that we have in DB. So read through is a little less efficient because the cache may try to cache unnecessary data which is not needed. But in case of cache aside, because we are only caching the data, whatever is requested, whenever there is a cache miss is when we are trying to populate into cache. So in that sense, it is more efficient because cache will always have the what is requested data, the highly requested data. Now, in case of read through, the cache handles the logic, application code. I don't have to do anything as application developer. So that is why it is simpler to implement the read through cache strategy. But in case of cache aside, since in this case, the application has to manage the cache logic, that is why it is complex. Finally, in read through, wherever you have high read loads, in that case, your cache and your DB always have to be consistent. So because of that, high read loads and consistent caching needs, you will be using read through. And in this, it is lazy. Like Cache aside lazy loading, keep this in mind, it is lazy. So it is only going to keep what is required. So it is doing it very selectively, and it is only needed whenever you have memory sensitive scenarios that you do not want to waste unnecessary memory. We'll only keep in cache whatever is required or requested. Next is the comparison of these three, the write strategies. The write strategies. Write around, write back, write through. Around is bypassing the cache. So it will write directly to the database, not the cache. In write back, we will first write to the cache and asynchronously to the database. Here to both cache and database simultaneously. Clear? Write around the cache may miss recent writes because I am not writing to the cache directly. Whenever I am reading, only then I am doing it. In case of write back, the cache may temporarily have uncommitted writes because the cache is doing async update. So at some point in time, the cache may hold writes which is not yet written to the database. But in case of write through, the cache is always consistent with the database. In write around, we are trying to avoid the cache pollution, and in this case of write back, we are trying to use write back strategy when we want to do batch writes, because you think of it, the cache at one point in time asynchronously it is going to push all the writes. So whenever you want to do batch writing, then you may want to use the write back strategy. But in case of write through, it is little slower, because when you want to bring your consistency up, the writes are going to be slower, because at the same time your cache and the database both needs to be updated. So you want high consistency, but it will be slower. Okay. In case of write around, the data is immediately in the database. In case of write back, the drawback is the data loss. Because what if the cache which is holding the uncommitted writes has failed to write to the database? But in case of write through, the data is written immediately to both. So there is no worry of data loss. When to use which one? The final question is, when you have write around, when you have read heavy workloads, don't have like much writes, infrequent writes, use write around, because I am writing directly to the database. Okay. And mostly I am depending on reading. So I don't have much writes to take care of. So in that case, cache, I don't have to write to the cache every time. So I will be using write around. I can bypass the cache. But if you have high write performance, you may want to write to the database, and high write also means you can batch the write operation. So, and if you want high write performance, but you can also tolerate data loss, then you use the write back. But when you need data consistency also, and you want the reads, like the frequent read will also happen. Like, see the bank ATM example, that is why I give. You have done a cash withdrawal or cash deposit. Just after that, doing a deposit, you are doing a withdrawal. So when you are doing a deposit and just after that you are doing a withdrawal, it is like you are doing a write and then you are doing a read. So you need high consistency. So in that way, write through strategy is the most favored one. So now we will talk about cache eviction and cache invalidation. Two very related, two very important things to know about cache. So when to use which one? So cache eviction is when you want your old data to be removed. So see, cache has a limit to the size, right? So for example, it can store only 100 keys. It will be of course more than that. 100 keys. It's a key value pair. So a key and a value. So there can be only 100 keys. So against 100 keys, it will store some value and we are getting the value of that. Now the problem is, if I want to store 101th key, where will I store it? If I have to make space for one more key, I have to remove one key out of it. So what is the strategy that I can use? So I can use any of these algorithms to remove that one key which I want to, I want to swap it for the 101th entry. So I can use least recently use the key which has not been accessed. Very obviously makes sense. Or maybe something which is least frequently used. So suppose you have, let's say, 3 keys. Among them, one was used 4 times, one was used 50 times, and one was used only 1 time. So it makes more sense for me to evict the key which is only used 1 time in a certain loopback period. It can be last 7 days, 5 days, whatever your business logic is. And the no-brainer is a FIFO queue. So whatever key came in first, the first entry will be removed, and in that way I will add the 101th entry. And the last one is random replacement. So randomly it is going to remove the data from the cache. So this is about the eviction, when you want to make room for some new key to be stored in the cache, because cache has limited size. But cache invalidation is when you want to there's a valid entry. Invalidate means what? There's a valid key value entry and you want to invalidate that. So when you want to invalidate something, which means you want to override or update that particular entry. So it can happen that you have a certain key value pair. So let's say I was storing some data, some count of maybe something like count of employees maybe. So I was storing that count of employee. Now that count of employee can change maybe in a day, in a 2 days, or maybe in a week. So if the count of employees is changing, let's say it is changing every 6 hours. So if the count of employees is changing every 6 hours, in that case, will I be able to show the same count that was, let's say, 1000 employees? And every time I am doing a page refresh, I am seeing 1000? No, I will have to increase it. You may also have seen like things like live scores, right? Although that is a completely different thing, but the thing is, I do not want to show stale or old data to the user. So in that case, don't want to show 1000 every time. So what can I use? There are different strategies. One is to use the expiry or the time to leave, that time to live, that okay, after let's say 5 minutes, I am going to make this data invalid, and because I have made this data invalid, I am going to do a fresh db call and get the actual data. So your data is automatically removed, and because it is not found, there will be a cache miss, and I'm going to get the DB data from the DB. So that is tricky, very tricky, because you have to know what your TTL can be. It should not be very low. It should not be very high. If you keep it like very low TTL, again and again your DB calls will be there, which is expensive. If you have your TTL very high TTL, then your user will keep on seeing a stale data. So you have a trade-off which you have to solve. So this is TTL is one of the very common thing which we use to invalidate the cache entry. Another is write invalidation, which means the cache will be updated whenever there is any. So it's like an event driven sort of. So whenever I have a data change, let's say in my DB I had 1000 rows. The moment I have a 1001th row entry added to my DB, I'm going to update my cache. Simple. So it's like a push technique. So whenever I'm doing some event trigger is changing, some change in the DB is detected, I'm going to change the data. So my cache's data will automatically get updated to 1001. And third is manual invalidation, which may involve your application code oriented changes, like your developers can manually clear or update again based on certain events, some business logic again. So these, the invalidation and eviction, you have to understand the basic difference is eviction is more about making room because your cache has a limited size, but invalidation is about when your data should not be stale. That you have, okay, I have 1000 keys in my cache, I have space for 1000 keys, but the keys value should be consistent, should not be very old. So if we do not want to serve stale data, we have to take care of cache invalidation. So the next segment is about the caching solutions which is available in the industry for you to get familiarity and for you to be knowing the names. So when we talk of in-memory caching, we have Redis, we have Memcache, and uh, Redis is an open source in-memory data structure which acts as a distributed cache, supports various data structures and all of that. So it is just for your knowledge so that you can know when to use which one. Memcache is also open source high performance. It's a distributed caching system. I've already discussed about distributed caching system, and it is simple and lightweight. But I think Redis is more feature heavy because of the data structure supports which it gives. But I don't want to go deep into any of the caching solution right now. If you want a dedicated video on any of them, let me know. Coming to distributed cache, the very popular one, industry-wide used, Amazon Elasticache. Although, whenever you want to switch to Amazon Elasticache, you'll have to make a lot of code changes. And Elasticache also supports Redis and Memcache. Externally, you do not have to worry about it. Hazelcast is also another distributed cache system which supports all of this. And another is application-specific caching, which is simple and local and easy to implement. Like EH cache is there. It's open source Java based cache. Spring cache, very common, comes with Spring framework itself and has all of these implementation. Caffeine is another caching library for Java. And it has all of these features, right? So what solution you want to use depends on a lot of R&D which you'll have to do, brainstorming based on your business use case and solutions. So this is just to give you a very brief, a very rough understanding of what are the industry wide used solutions. Finally, we'll wrap up by talking about when we shouldn't be using caches. So these are the points to keep in mind, because if your change in the data is too much, always changing, then there's no point, because again and again you'll have to refresh your cache, right? Then if the application has minimal user interaction, so see, your caching, the main point is to improve the user experience, the performance. And in order to do that, we were adding this another layer to reduce the latency, so that more load is not there, not the database is not getting overwhelmed. So that was the main point. So if it doesn't have that much traffic, of course for your personal project you're not going to add a caching solution. Then third is the data can be quickly retrieved, so your time taken to retrieve data from DB is very fast. Then you do not need, but only if it's an expensive, I have always said this, if it's an expensive DB operation, you're ever growing very large database, millions of rows, and then that is a DB, expensive DB operation, then you can try to think of using caching. Fourth, when strict data consistency is crucial and stale data cannot be entertained, in that case you will not be able to use a cache. When frequent writes invalidate the cache, reducing, okay, so again and again, if your TTL has to be such that, let's say every 1 hour your data is getting changed, so every 1 hour your data has to be changed, which means again you'll have to do a DB query to refresh your cache, then what is the point? And the last point is, if there is a compliance thing that using caching can pose security risk, and especially with sensitive information, then it doesn't make sense. So these are the points in which you have to understand that when it doesn't really make sense to use a caching solution. So with that, on that note, I'm going to wrap up today's video. Thank you so much for watching this pretty long video on caching, because this is going to set the stage, going to set the foundation for the rest of the upcoming videos. Like when I talk of CDN, many of the things you'll be understanding only because you have understood about caching. It's a very important pillar of system design. Thank you so much for sticking to the end of the video. And please don't forget to like and share this video, and don't forget to subscribe to my channel if you have liked the video. Thank you so much again for sticking to the end. Thank you so much. See you guys in the next one.